right, ladies and gentlemen, welcome back for another round. This is Mr. Doolin. I thank you so much for tuning in. Today what we're going to do is we're going to take a look at acids and bases. For most of you, this is going to be a somewhat of a review from your pre-AP days. All right, and so the very first set of acids and bases that we're going to look at are known as Arrhenius definitions of acids and bases, and this is probably what you are most familiar with at this point, right? Arrhenius says or states that an acid is any substance that produces H+, or you could write that as H3O+, that's known as a hydronium ion. So any substance that produces a hydrogen ion when put into water, all right? The Arrhenius base, on the other hand, is any substance that will produce a hydroxide ion when placed in water. And so a lot of the times, if you remember back in pre-AP, you'll see those as either HCl or something like NaOH. And you would recognize the HCl as hydrochloric acid as an acid and sodium hydroxide as your base. Now, the thing that we use in AP chemistry is we use the Bronsted-Lowry definition of acids and bases. And the reason we do that is because the Arrhenius definition is actually a pretty narrow definition as far as bases are concerned, right? Because we do have substances that are basic that don't contain hydroxide ions, and Arrhenius cannot classify those particular substances. So what we do is we take a more broad definition of what an acid and base is, which is Bronsted-Lowry's definition. And in Bronsted-Lowry, we are going to call an acid as anything that is a donor of a hydrogen ion, and then I'm just going to call that Bl. A Bronsted-Lowry base is anything that is going to accept that donated hydrogen, right? And so now you can see it's a little bit broader definition of what an acid actually is and what a base actually is as well, and how we function, all right? But this is the terminology that you're going to need to be able to function with in AP chemistry, all right? Okay, so now let's take a look at conjugates. Now, conjugate pairs are a very simple idea, all right? Conjugate pairs, by definition, they only differ by one hydrogen. And so it sounds relatively simple, and so let me give you an example here. So I take nitric acid, which is HNO3. I'm going to go ahead and show the dissociation in water, right? And so I get H3O+, so this is my hydronium ion, and I get NO3-. And so my question to you is, can you pick the conjugates out of this particular system? Well, let's take a look here. First, I'm going to look at my nitrate. So I'm looking at NO3, and notice I've got HNO3 over here and then NO3 on the product side. So notice it meets the definition of differing by only one hydrogen. Now, we know that this is the acid because it donated a hydrogen, right? And by definition, the NO3 would be my conjugate, and it would actually be a base because going in this direction, the nitric acid is donating the hydrogen. But now if you look at the opposite direction, going backwards, the NO3 will actually pick up the hydrogen if it's actually going in reverse. So generally speaking, your pairs, your conjugate is going to be the opposite of what it started as. All right? So looking at the other one, I'm going to look at water going to H3O+. So notice this is a base by Bronsted-Lowry's definition because it picked up a hydrogen and accepted that hydrogen. So over here we would label it as a conjugate acid. All right? Okay, let's take a look at another one of these examples. I've got NH4 plus H2O is going to give me H3O+, that hydronium ion again, and then NH3. So again, can you pick out your conjugate? So we're looking, I see NH4, NH3. I see this is my acid because it donated, which means the NH3 would be my conjugate base. And then the opposite there with the water, I'm going to call this water my base, and my hydronium is going to be my conjugate acid. The other things that you may recognize, or the patterns that you may see, is that the conjugates are generally going to be products. If you're looking at a particular reaction or a balanced equation, they'll be on the product side, all right? But if you're just giving it to as a pair in in context of a question and not necessarily an equation. You need to be able to recognize it both ways, okay? All right, and so now what we want to get to the point is, or get around to is the idea that acids only donate one hydrogen at a time. And so what do I mean by that? Well, we actually have different types of acids. We've got a monoprotic acid, which actually only has one hydrogen to donate. We also have a diprotic acid, which now has two hydrogens to donate. And then we've got a polyprotic acid, which has three or more hydrogens to donate. All right? And so an example of this would say, for monoprotic, we would say HCl is a monoprotic acid. Notice it only has one hydrogen. And so its dissociation would look like H plus Cl minus. A diprotic, a very common diprotic, would be sulfuric acid, which would be H2SO4. And so what you see here is that this will actually happen stepwise. It'll only donate one hydrogen at a time. So it goes H plus HSO4 minus, so this is step 1. And then step 2 would be HSO4 minus, goes to H plus and SO4 minus 2. So notice in this stepwise reaction, the HSO4 minus is actually an intermediate. When I add these together, it'll actually look like both hydrogens donated at the same time, but that's not the case, right? And then we also have polyprotics. The most common polyprotic that you'll run into is actually phosphoric acid, is H3PO4, but not necessarily the only one, all right? All right, the last word that I actually want to actually give you here is a term that's called amphoteric. And it's just one of those random words. It doesn't really fit in a whole lot of places. But if something's amphoteric, it can actually act as an acid or a base. And so water is actually a very common amphoteric substance because water can accept hydrogens and it can also donate its hydrogens to become hydroxide. And so water is your most common amphoteric, and you'll see some examples of that and see that embedded in all different kinds of places. I just wanted you to be familiar with the term there, all right? Okay, well, if you have any questions, I hope you got them down. I'll see you in tutorials for those. Otherwise, I will see you in class.